In today's video, we're going to talk about converting between polar and rectangular points. So remember that rectangular points are composed of an X and a Y movement, and polar points are just composed of a radius length and then the angle that you would need to turn to get there. They are like the exact same thing, okay? So like these two points are the exact same point, just one is named with the XY and the other with the R comma theta, but if you stacked them on top of each other, they land right in the same spot, okay? So we're gonna be looking to convert back and forth today. So when we do that, so we take this example and just look at how it converts to that other polar point, that'll help us with the formulas. So we've got this rectangular point here, which has an X movement of 3 and then a Y movement of 4. And what we need to do is just rewrite it in a different language. So it has this right triangle here. We just need for the polar points to actually go from to the R, or the length of this radius, and then theta. So how do we do that? Well, you've been doing it since geometry, because you just need to solve this right triangle and then just use these two pieces. So you know in this case that this X coordinate is 3 and that this Y coordinate is 4. So you should be able to find the radius fairly simply, because you should just need to do the Pythagorean theorem. And in this case, you probably already know that the R is 5, but the actual work behind it, right, would be Pythagorean theorem, doing 3 squared plus 4 squared, and then 9 plus 16, and then 25, and so then you get R equals 5, okay? So that unlocks the R value for our polar coordinate. So remember, polar coordinate is R comma theta. So now we already have the R, now we just need the theta. And so then the theta is this angle. Well, how do we find this angle? We have the opposite side and the adjacent side, so we set up a tan inverse function. Okay, so if we do the tan inverse of opposite 4 over adjacent 3, that'll give us our theta. In this case, then typing that into our calculator and getting 53.13. So that gets us our polar points. We just use the R and then the theta, so 5 and then 53.1. So those 2 points, 3, 4, and 5, 53.1, are the same thing, one in rectangular, the other in polar. So let's take a look at then going the other way, okay? So now if you have that polar point, and then you want to convert back to rectangular, so now in this case, we have, you know, the radius already given to us, and then this angle given to us. So now what we need to do is find this X and this Y. So now you're just going back to right triangle trig with an angle, looking for the adjacent side given the hypotenuse. So in order to find X, okay, we would be using a cosine function. So we would be setting up cosine of the angle equals the adjacent side over the hypotenuse. Then you can cross multiply and just type that into your calculator, and you would end up with your X value. Then you're going to do that very similar thing for the Y. In this case, the Y is the opposite, always will be. Okay, so opposite and the hypotenuse. So you're going to be setting up a sine function. Okay, so sine of the angle equals the opposite over the hypotenuse. Cross multiply. And then type that into your calculator, and you're going to end up with 4 equals Y. So your rectangular point is your X, which we got was 3, and then your Y, which we got was 4. Okay, so these are going to be the basics. It all stems just from solving a right triangle. So let's write it down in generic form. Okay, so if I just have some random point here in rectangular form, okay, so then this is going to have an X and a Y. So if I look at it as this triangle, So I've got this x coordinate, I've got this y coordinate. I'm looking for this, which we're calling the r. Okay, so in order to get the r of your polar, okay, so this r of your polar, you are going to need to do the Pythagorean theorem, right? So the Pythagorean theorem is doing x squared plus y squared and then square rooting it. So this will give you your r. Then to get theta, okay, we'll do the tan inverse because we're going to always have the y and the x from the rectangular. So we're going to have this opposite and the adjacent. So we're going to always do a tan inverse of the opposite y over the adjacent x. Okay, and those x and y are going to come from your rectangular point. Okay, now there is like a little bit of a trick for the angle if it's in the second or the third quadrant, and we'll talk about that a little bit later. But if your point is in the second or third quadrant, there is going to be something that you need to do. Okay, so just remember if it's second or third quad, then there is going to be something that you need to do. Then generic form for going from polar to rectangular. So again, if we just have some random polar coordinate, remember it's in the form r comma theta. So if we're taking a look and we want to be finding the rectangular, okay, so we're looking for this x coordinate and this y coordinate given, okay, that they gave us the r value and they gave us this theta. Okay, so if we have values in there, when we go to set up for x, you have something here, or you're looking for x and you know the r and the theta. Well, cosine connects them. Okay, so let's take a look at this. So cosine of the angle will equal the adjacent over the hypotenuse. Remember, x is what we're looking for because the rectangular, we need the xy. So we would multiply by r to both sides, and that would get x by itself. So if you're looking for the x coordinate, you do r times cosine of theta. Okay, you're given this r and this theta in your polar point. For the y coordinate, that's the opposite. So you're going to have sine of theta equals the opposite y over the hypotenuse r. Again, solving for y, so we're going to multiply that r up to both sides. So you're going to get y equals r sine of theta. So r times sine of theta, remembering that the radius is in your polar point that you're given and your angle is in there. Then you can just type these into your calculator to get that x and y. So let's take a look at a couple of examples. So in your Delta Math, it's gonna ask you for simplest radical form, which means you're gonna have to use the unit circle. So go ahead and pull one up on your computer or pull out your notebook that has it. Let's plot this one just so we can look at it. So 4, so 1, 2, 3, 4 on the angle pi over 4. So this is your r and your theta. So remember, we are looking for a rectangular point. Okay, so remember, rectangular point is x, y. So from those formulas for the last screen, your x coordinate is equal to your radius times cosine of theta. Okay, and your y is equal to your radius times sine of theta. So then just go ahead and plug these things in. Okay, so your radius is 4. Cosine of your angle is pi over 4. Okay, so look at your unit circle. Cosine of pi over 4 is square root 2 over 2. Then simplify this. So 4 divided by 2 is 2. So you get 2 root 2 for your x. Then go ahead and solve for y. So your radius again is 4. Sine of pi over 4. Sine of pi over 4, evaluate that on your unit circle, is also 2 root 2, or 2 over root 2. 4 divided by 2 is 2. So your y coordinate is also 2 root 2. Okay, so your rectangular point is x comma y, or 2 root 2 comma 2 root 2. Next one. Okay, so again, you can plot it if you want to. This one is not as easy of an r value to plot because it's not a whole number, so I'm just going to leave it. But r comma theta, I like to think of what quadrant it's in so I know if the rectangular coordinates are going to be positive or negative. So 4 pi over 3 is here. So your point is going to be somewhere in the third quadrant. So your rectangular points are going to be negative, negative. So go ahead and set these up. So again, your x coordinate is going to be r cosine theta. Okay, so the radius is 6 root 3, and then cosine of 4 pi over 3. So you have 6 root 3, evaluate cosine of 4 pi over 3. So again, look on your unit circle. Okay, it's negative 1/2. So 6 root 3 times negative 1/2 is negative 3. So half of 6 is 3 with the negative, and then the root 3. Okay, do it again for y. So r sine theta, your radius is 6 root 3 times sine of 4 pi over 3. So 6 root 3, the sine of 4 pi over 3 is negative root 3 over 2. So 6 divided by 2 as we simplify with this negative. So 6 divided by 2 is 3. So we have negative 3. And then we have root 3 times root 3 is root 9, which is negative 3 times 3. So your y value is negative 9. So putting those together, x coordinate is negative 3 root 3, and y coordinate is negative 9. So this matches the negative negative of the third quadrant, which is good. All right, then when we get into starting with rectangular and going to polar, okay? So now, again, we've got the little triangle to kind of think of here if you want to. And so your formulas here were r equals, so you're doing Pythagorean theorem essentially, so square root of x squared plus y squared. And then your theta is the tan inverse of y over x. So go ahead and find the r. Okay, so your x is 3, your y is negative 4. So you're doing 3 squared and negative 4 squared. So 9 and 16. So square root of 25. So you're getting r equals 5. So remember, we're doing r comma theta for a polar point. So now we figured out that the r is 5. Then to do the angle, we'll do tan inverse of negative 4 over 3. Okay, and as you do that, then you can just type it in your calculator. And get negative 53.13, and which matches this angle. So this could be negative 53.13 for sure. Okay, so that's fine on your test or your quiz. That's going to be totally acceptable. So negative 53.13 degrees. And so we've got the radius and then the angle. So now I'm going to do a couple examples where it's in that second or third quadrant to show you what we have to do in this case. Okay, so again, you've got your xy, you're trying to go to r comma theta. So to find the radius length, you need to do the Pythagorean theorem. Okay, so x squared plus y squared. So we have 16 plus 4. So we end up with square root 20. If we simplify that, okay, 20 is 4, square root 4 times square root 5. Square root 4 is 2, square root 5 doesn't simplify, so our radius is 2 root 5. Then when we go to find theta and we do the tan inverse, okay, so remember we're doing tan inverse of y over x, that's going to be our theta. So your y coordinate in this case is 2, your x coordinate is negative 4. So type in 2 divided by negative 4 and do the tan inverse of that. And you'll get negative 26.6 degrees. So keep in mind that this is the angle that we're looking for. So the angle we're looking for is from here to here. Whoops. from here to here, right? And now the angle that we just got, because tan inverse doesn't have the ability to kick out a number bigger than 90, so it goes between negative 90 and 90, what we just got in our calculator is this angle, okay, of negative 26.6. So when you go to write your polar point, remember, so there's going to be two options, okay? This first one I think is probably the easiest if you just think plotting this angle and flipping the radius backwards. So to do that, you can just take the angle it gave you, negative 26.6 degrees, and when you want the radius to flip backwards on that angle, you just make the radius negative. Okay, so then that's going to be okay. You'll go to negative 26, flip back on the radius, which will put you on that point. The other thing you can do is actually get this blue angle measure. Okay, so you've got the negative 26.6. So if you want this actual angle here, you would take the negative 26.6 and add 180 to get over there. Okay, so the other option is to keep the radius the same. Okay, so keep your 2√5 and then add 180 to this angle to get the third quadrant equivalent, which is 153.4 degrees. Okay, and then that would be fine. So either one of these is fine. So you have, you have two options, okay? Your two options are to make the radius negative or to take theta plus 180 when it ends up when your point is in the second or the third quadrant. So if it's in either of these two quadrants, you have to do one or the other of these. So let's look at one more in the fourth quadrant. Okay, so let's go ahead and find the radius. Okay, so you're just going to do x squared, so you'll get 25, and y squared is 1. So your radius is going to be square root 26, which doesn't simplify. Then you're going to do the tan inverse of y over x to get your theta. Okay, so we'll do 1 divided by 5, and then the tan inverse of that. So you're going to get 11.3 degrees. So remember, an 11.3 degree angle is here. Okay, so that is not this one. So you cannot just answer square root 26 comma 11.3 degrees. That's the wrong answer. You either need to make the radius negative so that if you go to this angle, then you kick back to that point. Okay, or you need to take and add 180 to this angle to get this actual angle, okay? In which case you would leave the radius positive and then you would use the 191.3 degrees for that. Okay, so either make the radius negative with the angle that you got from your calculator, or keep your radius and add 180 to the angle, one of the two. And that's only if it's in the second or the third quadrant. That's the only one that your calculator doesn't kick back. Then if it's on a quadrant, like on a axis, so for this one, we're at negative 3, 0. And then we want to write it in polar form somewhere between 0 and 2 pi, which means no negative angles in this case. So remember that we want, okay, so this is negative 3, 0 for the rectangular point. We want an r comma theta. Okay, so the radius is the length of it from the origin. So the length from here to here is 3, not negative 3. Lengths aren't negative. So you could write 3 and then use the angle. So then what's the angle from here over to here? Well, 180, okay, or pi, since this wants it in radians. So this one you can just count out to the radius and then use the angle. This one being pi, remember, pi over 2, pi, 3 pi over 2, okay, or 90 degrees, 180 degrees, 270 degrees if you're in degrees. So this example, 0, negative 4 root 3 is going to be down here somewhere, okay, so 4 times the square root 3 is like 6.9. It's going to be somewhere down here. Okay, but again, the length of this then is just that y value. Okay, so the length from the origin to that point is your radius, okay, which in this case is just 4 root 3. Okay, positive 4 root 3. And then the angle over to here, positive, because we want to be between 0 and 2 pi, is 3 pi over 2, or 270 in degrees. All right, so here's a screen that has the formulas on it, so you can screenshot that, write it down, use it for your assignments, your tests, your quizzes, whatever you need. So remember, when you're going from polar to rectangular, the x is the radius times the cosine of the angle, the y is the radius times the sine. Rectangular, Pythagorean theorem to find your r, tan inverse to find your theta. If it's in the second or the third quadrant, so if it's plotted here or here, if the point is in one of those two, then remember that you need to do that. Okay, either make your radius negative or add 180 to the angle.